if you look at the total reinforcing of the Earth's climate, it's increasing the greenhouse gases significantly. So if you look at this plot here, you can see the sudden increase that we have in the past few decades. So what's really happening here is that the amount of the CO2 that it comes in compared to the amount of the CO2 that we are reproducing or retaking from the earth is not the same. So if we are getting around now 9.1 billion tons of the CO2, the only amount that we are processing here is around 5 billion. That goes like almost 1/3 of that by the plants, and almost 25% of that is by the water surface of the ocean, and the rest will go to the atmosphere. If it goes to the atmosphere, it will form a layer. This layer, when the sun gets to the earth, it will reflect this heat. This heat goes to the CO2, and it will reflect it back into the earth. And that's simply what increased the temperature that we have. So this is the real problem that we are facing currently, and that's what we refer to as the global warming, and everybody's talking about. So in 2009, at Copenhagen Accord, they came up with a threshold, a limit. They said, we don't want this temperature to increase more than 2 degrees. But if we look at the current situation here, it is expected that by 2050, we're going to reach this 2 degrees. And this is now a significant impact going to be on Earth. So we need to do something. We need to do something in every activities we do, and the civil engineers has a lot to do with this, in order to make sure that we can extend this period and we are not reaching to the level that the temperature is increasing by 2 degrees. So before I go any further, there's a lot of discussion about sustainability, and this is the key word that everybody's using these days. So what is sustainability? I choose 4 different definitions for sustainability to share with you. One is to meet the needs of the present without jeopardizing the needs of the future, which means we're trying to keep here better life for the next generations. Another definition for that is an overarching conceptual framework that describes the desirable, healthy, and dynamic balance between human and nature. Then it's a system of policies, beliefs, and best practices that protect the diversity of the planet's ecosystem, foster economic vitality and opportunities, and create a high-quality life. And finally, it is a vision that describes that anyone, or planet that anyone can live in. If I look at all these definitions, I'll find these words. We're talking about the present, we're talking about the future, we're talking about the human and its relation to the nature. We're talking about something to control what we are doing. We're talking about policies, beliefs, but the most important thing is the ecosystem and economics. Anybody talk about sustainability that it does not provide some economic advantages, nobody gonna use it. So let's be frank about it here. It must also provide some economic advantages. And in order to do that, we definitely need to have a vision. Transportation is definitely a key part of this. If we look at the transportation, usually we are using around 40% of the energy. But if we look at the petroleum-based energy, transportation is usually around 57% of all the energy that is coming from the petroleum, which means here this is a significant part. So transportation is really a main cause for the emission that is generated around us. And this is coming from the different modes of transportation, if it's cars, vehicles, rail, ships, and so on. And then we have a different impact on the environment. Whenever we have congestions, we have more emissions that it goes to the air. Actually, I always think that the needs of the people are usually 3. You need to eat, you need medicine, and you need to communicate. That's human being needs. If we are talking about food, you need to transport it from one location to another. If you need to go to a hospital, you definitely need to have a vehicle to take you there. And if you need to visit somebody, you need transportation. So transportation is very, very important for a human being. But along with that, there's disasters happening because With the petroleum that we are using here, there is the emission that it comes during the process. There's also during the mining. All this is creating some pollution, and even sometimes it gets worse when there's some spill of the crude oil that a lot of you are familiar with. But there is another thing which is really important. We reach at this time what we refer to as the peak of the oil production. A lot of people think that there is a lot of oil, but the matter of the truth is, for example, Saudi Arabia, it costs them 1 barrel of oil in order to produce 100. But if it starts now costing 1 barrel to produce 10, then that country might not produce oil. So now we are at the peak, and this peak does not mean here that there is no oil. Some countries, they do have oil, but it's so deep and they cannot go or try to extract that oil. We are at the moment now that we reach that peak. A lot of the oil that is close to the surface, it's almost gone, which means the demand and the supply is different dynamics these days. And this is here the curve that's usually referred to as the Hubert curve. The Hubert curve is one of the curves that dictating or telling us now we reach this peak. Some countries, as I said, they've already reached that peak. But this is more affecting the third world countries, because the third world countries, they're going to be still using more oil. Even developed countries now, they are using some alternative energy methods, but they're still going to be needing for the oil, but it's going to be almost flat, while you're going to see the increase in the third world country or the non-OECD countries. So why we're talking about transportation here? It is the cornerstone for any economy in any country. Actually, any product that you are producing or you are importing, 1/3 of that cost is due to transportation. And this is something we can be discussing, of course, later or expand on this. So the transportation is support the GNP in any country. In some countries like the United States, 10% of their GNP is transportation. So it is very important. It affects the daily life of people, and if we look at any household, almost 20% of what you are spending usually in average, it goes into transportation. So this is very important. But also we need to look at it as an integrated system. So if you have a transportation system that it got congested, that's going to cause delay, that's going to cause more emission because of the standing, and that of course is going to require more energy. And when you have a still stand traffic or you have a slow traffic, it does more damage to your road. So let's assume here that there is a company who are producing a product and they are trying to ship it. When they ship this product, it goes to a network. This network is shared by the public. And you have to have a balance between the two. If you get this road deteriorated or having a problem, then we're going to have some delay in the shipment. If you get this delay, you're going to get some congestions. If you get the congestions, the shipment will not go to that place that it's supposed to. So that's in a very simple way now. You are having an imbalanced system that affects the economy directly. So if we look at the first phase here, we have to have a sustainable development of the economy if we are able to ship the products from one place to another place. If we look at the balance in the network, we are looking into economy, energy, and environmental sustainability, and to have the road in a good shape. That's what we call it, the good state of repair, or the state of good repair. So in transportation, when we talk about sustainability, we're not just talking about trying to use recycled material, we are talking about everything. We are talking about the research, we are talking here about the long-lasting roads, we are talking about planning to do the repair and the maintenance on time. So all this come together in order to have a sustainable system. So sustainability does not mean, under any circumstances, it's just to do recycling, although I'm going to be talking about that here in a little bit. So we have 3 points that we usually need to keep in mind. First, it's got to provide some economic advantages, which mean you have to have a cost effectiveness, fuel efficient, and energy efficient. As to the environment, it has to reduce the emission, the pollution, and the resource or the natural resource usage. And of course, for the society, it must be providing some safety when you're driving on a road. You definitely don't want a hazardous road. You need to make sure that it's secure and it's satisfying, which means that you do have the user of that road is definitely not feeling bad when they are driving. All these three are well connected, but I always like to use what we call it the donut system. The donut system is you have two boundaries. One boundary on the top, which is the environment. We want to make sure here that the environment is safe, the environment is not degrading, and you have the bottom boundary. And the bottom boundary means that the human being is not affected, which means here you don't have, for example, polluted water. This is something unacceptable. So in order to have a human being live in a good way, you need to be between these two boundaries. The boundary at the top, that the environment is in a good shape, and the boundary at the top, that the human life is definitely going on the right way. So in order to reduce the emission and the use of energy in transportation, we're looking into 4 different areas, and I'm going to focus on the one that I do a lot of work in. Travel efficiently, look into the renewable energy and alternative fuels, and have the vehicle technology. I mean, some of the vehicles, I'm sure you're all aware of now, we have completely autonomous vehicles, which means you don't even need to touch the steering. I mean, they just drive by themselves. The only reason that why it's not in the market is just because of the cost and the human mentality, but the technology is already there. And then, of course, the last one is the infrastructure, which includes the building and operation. And that takes us to something we refer to as the systems of systems. If we look at the energy as a system by itself, and we look at the urban transportation as a system, these two systems are interacting with each other. And I'm going to give here a few examples. One is producing the energy, regardless what the energy is, if it's coming from a power plant or nuclear plant. And of course, you have the urban transportation, including the building and the infrastructure. Good example, I can produce energy by having pipes in my pavements. These pipes are during the summer where you have the heat. It will heat the water. This water will go to storage. This water will go to buildings. And that will definitely save us a lot of energy. I look at porous pavement. Porous pavements means here that it will keep the water unpolluted. The one that it goes to the first layer of the pavement, it will just take it to the drainage system. And that's also another way that I can keep clean water. Also, we look into the energy harvesting from the pavement itself. If we put the piezoelectric in the pavement system, as your vehicle is passing on the pavement, because of the vibration that it happens, we are creating energy. This energy can light the bulbs in the street, that I don't need to get energy from somewhere else. This is harvesting the energy just from traveling over that pavement. Then we can reduce all the hazards that it happens to, or which I noticed that in the conference there's people who are going to be talking about the safety of the workers. It's very important that we can reduce the temperature of the asphalt by using warm mix. I'm going to talk about this a little bit. And also we can use recycling, which is a big area too, and that also going to be discussed here today. So let's talk a little bit about recycling. There's many things that we can put in the pavements, including reclaimed asphalt pavements, tire, rubber. Rubber, if you look at the tire that you have in your car, believe it or not, it has 32 components in it. Some of these components we can definitely use in our pavements because it has the polymer or the copolymer that it will provide us with SPS or make it a polymerized asphalt that can improve the road that we are driving in. Shingles, we don't have that much shingles here, but that's a very rich material in binder that we can take it from the roofs and use it in pavements. So by maximizing the recyclable products, we can now help the environment while at the same time save money. But also, we can also use the warm mix or have innovative pavement surfaces. As you can see here that the water in one side does not exist, which means here more safety for our drivers. And also we can improve the friction by using sprinkle mixes, which is also a very innovative technique that we have been using recently. This is not just economic impact and environmental impact, but now this is affecting the community and make it a livable community. So let me expand a little bit here about recycling materials or reclaimed asphalt materials. There is many advantages for this. First, in a place where you have the natural resources are limited, that will allow us to replace the virgin materials. Not just here, but everywhere, you have a shortage in landfills. I mean, at one point, this is going to be filled. So this is one way to reduce the landfill. And we can also engineer these products in order to make sure that it will perform like any other roads or even better. And that's where the engineering becomes important. I always, when I talk to my students, I always tell them that the difference between an engineer and non-engineer is the engineer, he does the right thing, but also saving money. Because anybody can design things, but not anybody can design the right thing and at the same time saving money. So that's very important. And I'm going to repeat this more than once, that if we don't have an economic impact, people will not be using recycled materials. If we look at the trend now of using recycling in asphalt concrete, it is definitely increasing significantly over the years. It's a very simple process. You mill the road. Even in Ramallah, you can see that. There is some roads already milled, just I think for hazardous reason they have it. But you mill the road, you take this material out. This is here a particle. It's usually still coated with asphalt. You put them in stockpiles. Instead of using just one stockpile, you fractionate it. You put them in different piles, and that will make the quality much better in a very simple way. We need to make sure that we calculate how much asphalt you have in the existing material. And that's something we need to understand, that when you use the recycled material, sometimes it blends, sometimes it doesn't. So this is something we need definitely to know before we start using this technique. Then in the plant itself, we need to know where to add it. That's also very important. And then you have the paving process. After we are done with this, we need to make sure before we put it into the road that we understand the properties of this material. We need to look at the ability or the potential for cracking, if it's fatigue or low temperature cracking. We need to look at the strength of the material, what's the modulus of the material, how it's going to react to the impact of the temperature and the vehicular loading. And that's usually some of the tests that we do. Right now, it is very easy, in my opinion, and it is safe and successfully done to go ahead and include up to or a little more than 50% recycled material, and we can engineer that. The people who deals with pavements, they know some of the terminologies or parameters here, but the one that I wanted just to focus on, and that's why many of you who read about the recycling, they usually read successes and failures. If we keep something, we call it the VMA, or voids in mineral aggregates, constant, we can add the different percentages of the recycled material and we can achieve a good design. So in a way, it's a very simple approach sometimes, but people, they may ignore it during the process of building the volumetric. This has been recently published in some of the work that we have done at our lab. But away from this, let's look at some of the advantages. The cost is less, so we have some economic advantages. Energy, I'm using less energy, and I'm having less impact on the environment. So here, I can achieve all these three when I'm using recycled material and if I'm using it correctly. Last year, we had a project, we call it the Total Recycle Mix. This one, it has a complete recycled material with the except of 3%, which is the binder that it was used. We use steel slag around 15%, recycled concrete around 27%, wrap around 53%, and it was fractionated, different sizes. Recycled shingles, which is very rich in binder, and we use just 3% of fresh binder. And from that, we got a good mix. This mix is in place, and it's already built. So here you have almost, they call it total, or we call it total recycled, because you have complete recycled materials except the 3% of asphalt. And the 3% asphalt that you are adding, it is usually very, very soft asphalt in order to make sure that there is no brittleness of this material. This is how the mix looks like inside. You can see the pieces of the concrete, the slag, the wrap, it's all together very nicely interlocked. But the most important thing is that we are getting a very stiff mix, and that's again where the engineers come. The engineers will make sure that this mix is not as stiff, because if this mix is stiff, this means it's going to crack. So in order to prevent this mix from cracking, we use a softer material in order to bring the curve, which is here, the lower curve here. This is a creep compliance, and you don't want it to be very low, because if it's very low, this means that this material is stiff, so we need to bring it up by using a softer binder. Also, as we are looking forward, we're looking